What I've got here is a module to receive a radio time signal. These radio time signals are broadcast from various stations over the world. In Europe, one is in Germany. It's called MSF 77 from 77 kilohertz. And in UK, the time signal is broadcast on the 60 kilohertz frequency, and this module, together with this ferrite antenna, is able to receive this signal. This is around CME 6005. That's what this blob here on the PCB is. This is IC that is able to tune in to this antenna, the frequency, 60 kilohertz frequency, and then output pulses that can be picked up by any other circuit. It's running on 3.3 volts. So here the pins are positive, 3.3, ground is pin second from the right here. Then there is enable pin third from the right, and that needs to be connected to the ground. So middle pins are basically connected together, and then signal out is the fourth pin from the right. I connected this to oscilloscope, and that's what I have on the screen, oscilloscope screen. Here I just have an LED connected to the to this board that is showing the signal, the pulses that are received. So it blinks at 1 second interval, although you can see that occasionally it is the blinks are doubled or are longer, shorter. That's because some data, or data about the time, is being transmitted at the same time as this 1 second, at the 1 second pulses. So basically every second there are 2 bits of information transmitted. So apart from first second, second 0 at the minute, at the full minute, all other seconds from 1 to 59 contain information. So there's 118 bits of information being transmitted. This circuit here is basically 2 transistors that convert the voltage. I run this on 3.3 volts. You can see here is a power supply that gives 3.3 volts to the CME 6005. It is capable of running from up to 5.5 volts of power supply, but for some reason the specs for this particular model comes at the maximum voltage of 3.3 volts. I haven't tried to run it from 5 volts. I'm quite happy. It's probably going to be decoded by Arduino anyway, that contains 3.3 volts converter, so I'm quite happy to run it on 3.3 volts, but that's the reason why I converted the voltage for the LED to 5 volts, and it's running from the other power supplies is running on 5 volts, and that's what the LED is running. It needs to be oriented sort of north-south, so it needs to be perpendicular to the, in my position, where I live, to the north-south direction. So it needs to go towards the transmitter that is that way. If I turn the aerial like that, then the signal stops. Basically there is no signal, or you can see there is lots of rubbish being received. So the aerial is actually directional. Here we go, and now it starts receiving signal again. It is quite prone to any interference on the 60 kHz, but even putting my hand over it stop the signal, stop the signal being received. So it's actually quite sensitive to any interference. So it is important how this antenna is being oriented and what is around. So here it is connected to oscilloscope. Here is a probe. Here is an oscilloscope, and that's the output on the screen. That's the output on the oscilloscope. You can see the pulses received every second, and you can see the bits of information depending on the width of the pulse. All right, and the beginning of the minute is going to be marked by the quite a long positive pulse and then negative. That's the beginning of the minute. Here we go. So that's the beginning of new minute, and then you can see bits of information being transmitted. Everything smaller than 1 square and 100 milliseconds. So 1 square, 1 division here on the screen is 100 milliseconds. Everything shorter than 100 milliseconds is interference. All these spikes and shorter pulses, that's the interference, it's noise. The valid information is coming as a multiple of 100 milliseconds. Let's make it a little bit more dense. Let's run it a little bit slower. So if we try and do that, we should be able to see the signal has been more condensed. It's much more difficult to interpret, but you get an idea of how it looks like. Now this signal is inverted, because in reality the signal is like continuous carrier, and then drops in the carrier that are positive bits. But here we have signal that the CME 6005 has 2 outputs. In this particular PCB they only output positive pulses. There is no access to the negative pulses, but I can access this here through the NPN transistor. So in a moment I'm going to actually change the output to my transistor, and we should see then an inverse signal. Let's do it. Alright, I changed the probe and connected it to the NPN transistor that is connected to the output of the positive pulses of the CME 6005, and here we have actually how the actual carrier looks like. So you can see the carrier going here, and then breaks in the carrier, kind of carrier off, and then are bits of information. So I have inverted and non-inverted output from this circuit, and that's also the reason why I use these transistors here, because I can then have 5 volts signal that can go into digital inputs of Arduino, and I have a choice between the non-inverted and inverted signal. So that's the whole purpose, not only for LED but also for the Arduino 5 volts input. And this is 5 volt signal. There is 1 volt per division. 2 volts per division, and we have 2.5 squares here. So this is 5 volt output. It's slightly less than 5 volt actually, but it should be alright for the Arduino digital input. So that's how it looks like. Let's change this again to 100 milliseconds per division, because that is, I think, far more informative. You can see it much nicer and clearer how this MSF signal is being transmitted. So that's actually how the carrier is transmitted. Right.